live now. Can anyone confirm if audio and everything looks fine before we get started for today? And like, how many problems were you guys able to solve with people in the chat? Like, that will give me some estimate on which problems to focus more on and which one we can probably move a bit faster. Okay, looks like G, E, G, D. Some people got L, 3, 1. Okay, first question, like 1 is fine. Like for the first corpus, but we will probably improve as the time goes by. Okay, couldn't solve it. Okay, solve 3. Okay, I will wait for 1 minute more and then we will get started. Like D can be done with DSU, but strictly not necessary. Although I, in fact, did DSU. Okay, so it's nice. Okay, I think I will start now. And just give me 1 more second. I think I am good now. So let's get started now. Okay, first problem says Sakurako's exam. Today Sakurako has a math exam. Teacher gave the array consists of A1s and B2s. In an array, Sakurako must place A plus sign and A minus sign in front of each element so that sum of all the elements in the array equal to 0. Sakurako is not sure if it is possible to solve this problem. So determine whether there is a way to assign sign such that sum of all the elements in the array equals 0. Since we want sum of all the elements equal to 0, what we can do, like here we have A1s and B2s. First of all, let's forget about 2 and let's see, can we make sum equal to 0 using just A? If number of A's is odd, then the answer will be no. Because like whenever you add +1 or you subtract -1, the current sum changes from odd to even and even to odd. So you must have A equal to even. This is the necessary condition. Like A must be even. Now here like we can have A by 2 +1 and A by 2 -1. We can try to do similar thing for B as well. We can have B by 2 +2 and B by 2 -2. And if B is odd, we can probably change one pair here to make it +2 -1 -1. So overall the condition turns out to be answer is no if and only if A is odd or A is 0 and B is odd. Like these are the two only conditions when the answer can be 0, otherwise the answer is always yes. And you can probably greedily try to find that answer. Like the idea is like if B is odd, you take 1 +2 and then -1 -1. After that both A and B will be even. So you can have half of them as +1, half of them as -1, half of them as +2, half of them as -2. Any questions on the first problem before I move on to second problem? So if n is odd, print no. If n is 0 and like I can probably write it in a better way. If or if a is 0 and b is odd, print no, otherwise print yes. And like this should be the solution for this problem. Okay, I will move on to the next problem then. One. Yeah. So moving on to next problem, it says a beautiful matrix is a matrix that contains one of its edges, ones on its edges and zeros inside. Some examples are given like this. Today, Sakurako was playing with a beautiful matrix of size R cross C and created a binary string by writing down all the rows of the matrix starting from the first ending with the R. More formally, the element from the matrix in the ijth column correspond to this index in the string. You need to check whether the beautiful matrix from which S was obtained could be squared. In other words, you need to check whether S could have been built from a square beautiful matrix that is one with R equal to C. Okay, this concern I did not realize it's written in the contest. So what we really need over here is so what we can do is like first like n, which is the length of total number of characters we have, should be a perfect square. So based on that constraint only, we can know that R will be equal to C will be equal to square root of n. So if n is not a perfect square, directly print no. And if n is a perfect square, we can first try to create an R cross C matrix which contains all the zeros and ones. These parts will contain zeros and everything here would be 1, 0. And everything here would be 1. We can first create a matrix, beautiful matrix like this. And then we can try to create string S by first taking this row, then appending this row, then appending this row and so on. And at last we can check the string which we have obtained is equal to the original string we have. And this will be the solution for this problem. Probably let me just share some code. So like first we can try to find square root of n. Like probably an easier way is to just this, if n is not a perfect square, directly print no. First row must be all ones. Last row must be all ones. First element of each row must be all ones and last element of each row must be all ones. And then we can try to see what will be the target string. And at last just check if both the strings given in input and this string is equal, print yes, otherwise print no. Okay. So this ends up being the solution of second problem. So any questions on problem B before we move on to problem C? Okay, moving further, it says longest good array. Today, Sakurako was studying arrays. An array A of length n is considered good if and only if A is increasing. That is, all the elements are increasing. And the difference between adjacent elements are increasing. So basically, you can see like this is how you find. Sakurako has came up with boundaries L and R and wants to construct a good array of maximum length, where L is all the elements are between L to R. Help Sakurako find the maximum length of good array for given L and R. So what we can see is like, let's greedily try to create like as many elements as we want. The simple idea would be let A1 equal to L. And because the difference must be increasing, we can take A2 equal to 2. Here the difference is 1. So we can take A3 equal to A2 plus 2, which would be equal to L plus 3. A4 should be equal to A3 plus 3. Difference increases by 1. And so on. We can keep trying to get elements like this as long as we can until all the elements are less than R. And like now if you try to generalize, like if there are n elements, an would be an minus 1 plus n minus 1. You can see like the first time it's 0, and it will turn out to be L plus sum of first and minus 1 elements. It will be equal to L plus 1 plus 2 plus up to n minus 1. And you know the formula of sum of first and minus element, so it will be equal to n into n minus 1 by 2. Like this is the sum of first and minus 1 element. And we want this to be less than equal to R, right? Because all the elements must be less than equal to R. So what we need is largest element n such that n into n minus 1 by 2 is less than equal to R minus 1. And like this is all we need in this problem. Now once you arrive this equation, any question so far, like how I came up with this equation here? Okay, now there are many ways to do it. You can probably binary search. So like, what is the best we can do? Like the smallest element we can take as the first, like you see all the elements are increasing. So like the smallest element we can take can be equal to L here. And because we want all the differences to be increasing as well, what we can take is A2 minus A1 equal to 1, A3 minus A2 equal to 2, A4 minus A3 equal to 3, and so on. an minus 1 equal to n minus 1. So now when I try to write, or simply put in, if I add all of these equations here, what will I get? An minus a1 equal to sum of all the numbers 1 plus 2 plus up to n minus 1, and sum of first n number, like sum of first m numbers is, we know that this is sum of first m numbers. So if I put m equal to n minus 1 here, I would get an minus an this. We can take this equal to L, and so that an becomes n by 2, and this must be less than equal to r. So we need the largest n such that this condition holds. Now once you have this, there are many ways to do it. Like you can probably pre-compute all the values, all of these values, and try to see for which n it's the smallest, like based on r minus l. Or you can probably, I think running a for loop might be enough for this problem based on the constant. So this ends up being the idea for this problem. Or another way to see is like keep iterating over here. This ends up being the solution for problem C. Any questions on problem C? Like you can also use quadratic formula, like there are many ways to do it. And like someone in the chat asked, like, can I explain like the perfect square condition for problem B again? So like the string contains total number of elements we have, right? And total number of elements in a matrix we have would be r cross C equal to n. And for a square matrix we have r equal to C as well. So now you see, like if you put r equal to C here, you will get r square equal to n, implies r equal to C equal to square root of n. And like we need, and this is why like perfect square means there exists some element, if you multiply it with itself you will get that element. So any questions on problem C before we move on to problem D? Okay, for a certain permutation P, Sakurako calls an integer j reachable from I if it possible to make I equal to j by assigning I equal to pi a certain number of times. For example, if like probably let me take first read it. If P is equal to 3, 5, 6, 1, 2, 4, for example, 4 is reachable from 1, because I equal to 1, now you assign I equal to pi, you will get I equal to 3. Now you assign I equal to p3, you will get 6. Then you assign I equal to p6, you will get 4. Now I equal to 4, so 4 is reachable from 1. Each number in a permutation is either colored black and white. Sakurako defines f of I as the number of black integers that are reachable from I. Sakurako is interested in f of I for each I equal to 112. But calculating all these values becomes very difficult. So she asks you as her good friend to compute this. So like for example, let's look at one of the samples here. So let's pick this array. Three, 5, 6, 1, 2, 4. This is Pia. Let's also write I. 1, 2, 3, 4, 5, 6. Now what we can do is like we can create a graph with 6 vertices and create directed edges from I to Pi, because that is how we can reach this graph, right? So in this case we would have edges from 1 to 3, 2 to 5, then 3 to 6, then 4 to 1, then 5 to 2, and then 6 to 4. Like now if you see this graph, you see like this graph contains 2 cycles. One of them is this and one of them is this. So if we know for answer the value for f of 1, we also know like the answer would be same for 3, 6 and 4. Similarly, if we know for 2, the answer would be same for 2, 5, both of them. And in general, this will hold, like this graph will only contain cycles here. So what we can do is we can try to find all the cycles in this graph, and for each cycle we count how many black nodes are there, and then that answer would be same for every node in this graph. Any questions on the idea first before we jump on to implementation? Like if you create a graph from where there is an edge from I to Pi, because from I you can assign I equal to Pi to reach this new number. Yeah, like there was a black and white thing as well. Like in this example, like in this example, this all of these nodes are white. All of these nodes are white. And this is a black node. Probably black is not visible. Let's probably color it pink. So if you look at this graph like this, so this node would be black. So the answer for 2 and 5 would be 1. Or wait, these are the black nodes. 0 was the black node. So this is white node. This is a black node. So the answer for all of these 4 vertices would be 4, and the answer for 2 and 5 would be 1. like the intuition here is like, for if we have an I, we can change that I to pi. So the easiest way is to just create it as a graph and see from which node you can go to which node there. Like that is the first thing. And now why it turns out to be a cycle is something probably like very specific property for a graph like this. And the best way would be to probably see why it happens. Because the idea is like, you see like from some node you will go to some other node, you will go to some other node, you will go to some other node. And there would be some point when you will reach one of the existing vertices again. I am not saying that you will have complete cycle, but at least you can see like you should expect a graph like this, right? Because like when you go to the n, when you go forward n times, the n plus 1 time any vertex you reach would be the one you have already visited before. So like let's leave intuition first. What my claim is like, the graph should be like this to begin with. Like some set of branches here, and then you stuck in a cycle so that you can keep going forever. Like at least see like you will have a graph like this, right? When you create an I from pi edges to begin with. And like this type of graph is known as functional graph. And this happens when you had this constraint. But if A is a permutation, it turns out that this graph will have only cycles, no branches standing outside. For permutation, this graph ends up being like this. And like this type of cycles has a specific name, permutation cycle. If you had just this constraint, you would have obtained some graph like this, and this graph is known as functional graph. And if you say like along with this A is also a permutation, then you will always end up this being a cycles here, and these cycles are generally known as permutation cycle. And yeah, like Shivang mentioned correctly, like in a permutation cycle, like each node will have only one in degree and one out degree. And if you see this graph has more than one in degree. You have edges from I to pi, right? So for each I, there would be only one outgoing edge. Because in permutation, like only value appears, each value appears only once, are distinct. A cycle to pi will also have only one node before it. So one incoming edge. So if each node has one incoming, one outgoing edge, then that can only happen if you just have a bunch of cycles in your graph. Any questions on this one before we move on to the next part for this problem? Okay, now the idea would be like, we can try to find all the cycles, and then for each cycle count how many black nodes are there and update it for each of the nodes. Like I can probably show the implementation here. Let's create a visited array. If visited I is to continue, otherwise LLI x equal to I, and keep going for all the vertices as long as visited I is not 1. Like probably let's create a set, or like once you are done with this, you can count black nodes here. Black node is 0, I believe, not 1. 0. And then for each node in cycle, you can update this as a count. And at last print all the values of Fy. This ends up being the solution for problem B. Wait 1 second. Circle. Okay, this should be as long as visited is false. You keep going. Any questions on problem D? Yeah, like there are ways to see specific language codes here. Like you go to status tab and you can filter based on language here. For example, if you want Python. You can see all the Python submission. If you want for problem D, you can probably look at problem D. And if you want even the accepted verdict, you can also mark it as accepted. Like how to solve it without graph. Like if you look at this implementation, like there are no specific graph thing here. But to understand why this works, you need to understand the graph and underlying idea here. Like you can just say visited node. Now there is no reference of cycle here. But to understand why this idea works, you will have to understand this graph idea. And like there is no shortcut there. Like if you look at just this code, like probably say any more questions on problem D before you move on to problem E? Okay, yeah, I will probably move on further. It says alternative string. Sakurako really loves alternating string. C calls a string of lowercase Latin letters an alternating string if characters in the even position are same. If characters in odd position are same and the length of string is even. For example, string AB is good because you see for all the characters have only A, for all the characters you have only B, and total length is even. GG is also alternating, like all the odd characters have G, all the even characters have G. It's nowhere written that the characters at odd position, even position must be different. While ABA is not good, like here all the characters at odd position are A, even position are B, but the length is odd. Or GGWP is not good, although the length is even, like odd characters contain G and W and even characters contain G and P. As a good friend, you decided to gift such a string, but you could not find one. Luckily, you can perform two types of operation on this string. Choose an index I and delete the ith character from the string. That will reduce the length of string by 1. This type of operation cannot be done more than one time. Choose an index I and replace SI with any other letter. Since you are in hurry, you need to determine the minimum number of operations required to make an alternating one. So, like this is the problem statement. Any questions on the problem statement before we jump on to the solution? Like let's first solve for a simple case when n is equal to even. Now for even case, one second. That's 11 function. Now n is even, like if you delete one more character, the length will become n minus 1 and which would be odd. So for even case, you can never do this operation. So the only choice we have is like we can only replace some of the characters here. So what can we do here? Like we can look at all the characters at odd index and characters at even index. Keep which appears maximum times. Keep that appears maximum time and replace everything else. Everything else. Any questions on idea like how do we solve for n equal to even? Now when we have n equal to odd, and because we want even length, we should do this operation at least once to make the length n minus 1. So what can we do here? Like we can try out for each index I equal to 1 to n. See what will be the string after we delete the ith character. Like we can keep a count of using prefix sum. Like we can keep a count of all the characters which are at odd index. Like like we can count how many A exist at odd index, how many B exist at odd index, similarly how many A exist at even index, and so on. Similarly here also, like in this area, if we have number of A's at odd index for each character from A to Z, and for A to Z at even index, then you see, like once you delete this path, like probably let me show you around. And let's say we delete S4. Our string, new string would be T1 this, T2 this, T3 this, T4 this, T5 this, T6 this, T7 this. So like any character which is at odd, which remains at odd, even remains at even. Here any character which was at even index comes to odd index, and any character which was at odd index comes to even index. And like this would be the idea, like so like we can maintain how many characters, like how many times A appears at odd index here, how many times A appears at even index here. Similarly we can keep a similar count of size here, total an array of size 52 on this side and array of size 52 on this side. And then we can separately count, like if we want to, let's say, keep A at odd index, total number of times would be like A odd here plus A even here, because like character at even position comes out to be odd. So if we have like this count for both prefix and suffix, we would be able to count, like if we delete this character, how many times a particular character will appear in overall A, B, C and so on. And then we can look at which one appears maximum number of times, and we can only keep the one which appears maximum for odd, one which appears maximum for even, and replace all the other characters here. And this would be the idea for this problem. Any questions on the idea first before I jump on to the implementation? Yeah, I can explain it on one of the test cases, like any test case which I should try. Time complexity is approximately order n, or you can say 26 into n, something like that, which is 26 is a constant, so it will be order n at the end of the day. Like I can take one of the sample, any example, which one I should take? Okay, let's take this sample 3, 1, 2, 3. Like 3 looks out to be quite simple. Like on C, third sample, you can just delete B character here. Let's say this is our string. Now let's say if we delete character, A odd count is 2, B even count is 1, and everything else is 0 here, all the other characters. Similarly on this side, like 0, 1, 2, 3, 4, 5, 6, 7, 8. So like B at odd count is 2, these two characters. This is order. A at even count is 1. C at even count is 1. This is how the initial string looks like in this area and this area. Now once I delete this character, number of A's at odd index would be this plus this total 3. Similarly, like for B at even index, you will have this and this total 3 times. And the number of operations you will require would be 2. Like these are the operations you can save. And you will have to delete this one character and one operation here, so total 2 operations for this case. Wait, like the string is not even, like probably let's just put a B here. So this was the idea. Now what we can do is, like 2 operations would be one deleting this character and one removing this C. Like we deleted D only because like we looked at, like if you keep, let's say C at another index, like total number of times, like if I delete this character, then the number of times A appear at odd index is 3 and B appears at even index is 4. And this is the maximum you will get. Had like if you have decided to keep C at even index, let's say, the count you would have got was 4 and you will have to delete these 4 occurrences as well. And total number of turn out operations would turn out to be 5 here. 1 for delete and 4 for replacing this. So what I am looking at is like, look at all the characters at even index, keep the one that appears maximum number of time and replace all the other occurrences. So for even, like you have 2 choices here. Either you can keep B at even and save 4 characters, or C at even and save 1 occurrence. And if you want to keep C at last, you will have to change these 4 B's to C. If you keep B at last, you will have to only change 1 C from B 1 C to B, and like this turns out to be the idea. Like if n is even, this would be the frequency of any character which appears maximum number of times. We don't have to print the maximum string, by the way. So you can directly use this string. And the number of operations you would require would be max odd minus max even. Yeah, like only minus ones are remaining. Like now we can maintain similar. Like let's just keep these 4 arrays here. Like we can first let's try to count for each character how many times something appears. Like let's first populate after odd. Let's say answer is infinity initially. Removed IDX. If this is odd, after odd at character C reduces. After odd at character C. Now we need max odd and max even, similar to this before. The C count would be like for odd index before odd C plus after even C, because we have deleted one character, parity has changed. Similarly, we can try to find max even. And the number of operations we would need would be minimum of answer comma n minus max odd minus max even. These are the number of operations we need for replacing and one for deleting the character. Now we can put this character again for the before part, so that when we move to the next index we will have this correctly. Any questions on this before we probably move on? Like it's just only like this max odd and max even keeps track of even remove. Like these are the indexes you can save. So like n minus m, like you will have to do something there. So delete is already counted there. Wait 1 second, did I miss something here? Okay, this should be plus plus. Any question on problem E before we move on to problem F? Okay, like my main idea is like for each character, let's say I have fixed which index I want to delete. Then I want to count how many times A appears at the odd indexes after removing some particular character. Or how many times, let's say, D appears at the even indexes. That's what I need, like at the end of the day, because I want all the characters at odd index to be same. What I can see is like the character which appears maximum number of times in my final string, I will keep it as it is and change all the other indexes to that character at odd indexes. Similarly, I want to know like what character appears maximum number of times when I only look at the even number of indexes, assuming that I have already deleted the character I want, so that I can keep the one which appears maximum number of time and change all the other characters at even places to that character which I want to keep. And then my idea was like the way to do it would be like for each character, keep a count of how many times that appear at odd places and how many times it appear at even indexes before the character I want to delete. Similarly, also keep a count of for each character how many times it appears at odd indexes and even indexes after the character I have deleted. So initially I start with this. First, let's say I am here. So I can put all of these characters in my count for even and odd of the after the current character I removed. Now I remove this character. So my after count pointer moves here. And then based on whatever data I have in odd and even, I try to finalize which character to keep at odd index and which character to keep at even index. Then I move this pointer a bit further and keep it like this, boundary like this. Now by adding this A in my character arrays for before. Now I delete this B from my characters of after, so that my after character only contains this character and my before character only contains all of these characters. Based on which character appear odd even times, I'd finalize which one to keep, which one to delete, find the number of operations. Now I move by before pointer here, something like that. By adding this B in my vectors for before. Now I delete again A from my characters for after. So this is how it looks like. This is now deleted. I try to finalize which character I want to keep at odd and even vector. And then I add this back to my characters for before. Then I delete D from my characters for after. Try to finalize which character I want based on the data here for these two vectors. And then I move further and I keep going. Like probably you can submit for X, you can also submit the code which generates the vector you want. So instead of giving the file, you give them the code there. Codeforces will compile it and get it done. Any more questions on problem E before we move on to problem F? Okay, moving further to problem F. Okay, Sakurako has a box with n balls. Each ball has its value. She wants to bet with her friend that if the friend randomly picks two balls from the box, it could be two distinct balls, but they may have same values. The product of their values will be same as the number that Sakurako guessed. Since Sakurako has PhD in probability, she knows that the best number to pick is the expected value, but she forgot how to calculate it. Help Sakurako and find the expected value of product of two elements of the array. And it asks us to do it with some mod here. Like this, I would say, is a random story so far. What it says is like this is the only problem statement we should care. Like we have to find the expected value of product of two elements from an array, and array is given to us as input. So like if you have n elements, the number of ways to pick any two character would be nc2, which is n into n minus 1 by 2. And since each pair can be picked with same equal probability, expected value would be sum of pair of products divided by n into n minus 1 by 2. Any questions on this equation first? Like generally this is how you calculate, like for example, if you have a dice, what is the expected value? You count what all values you can get, which would be 1 plus 2 plus 3 up to 6, and then divided by 6 over there. Or another way is like for each pair the probability to get is same, which would be 1 into n minus 1 by 2. So you can also say like p into 1 plus p into 2 up to p into 6, which would be p into 1 plus 2 in case of dice. And it turns out to be like p is, like in case of dice, the probability for each any number is p 1 by n. So it turns out to be 1 plus 2 up to 6 by 6, something like that. So any questions? Like once if we know that sum of product of each element, then this is the would be the formula for the expected value. Now our problem reduces to count sum of pair for each product and see like how does all the pairs look like. A1 into A2 plus A2 into A3 plus A2 into A1. Like probably let me just write it again. Like sum of all the pairs would be look like A2 into A1 plus A3 into A1 plus A3 into A2 plus A4 into A1 plus A4 into A3 plus A2 plus A4 into A3 and so on, a formula like this. Like the number of pairs we have with two numbers is n into n minus 1 by 2. These are the total number of pairs you can get, assuming like you don't really care about the order of numbers here. And like it says randomly pick number 2 balls from the box. So like we random pick 2 balls. So here we can assume that probability of getting any pair would be equal. So if you have 6 possible pairs, then probability to get any pair would be 1 by 6. Or if you have, let's say, 50 possible pairs, then probability to get one particular pair would be 1 by 50. And that's how I came up with that denominator. Like find the sum of all of these values and divide it by total number of pairs you have. And now if you look carefully, like we can write this in another way. A2 into A1 plus A3 into A1 plus A2 plus A4 into A1 plus A2 plus A3 and so on. So you can in fact generalize this. You can maintain one running sum of all the numbers you have visited so far, multiply it by current number, add that to the current number and keep going it. This is the value we need. And this ends up being the solution for this problem. PVR sum 0. First, let's say numerator plus equal to PVR sum into x for every element what was multiplied by all the numbers previously, and add this number to PVR sum for the x iteration. Denominator is number of pairs and you can print numerator by denominator now, and this ends up being the probability here. Like be careful, it is modular int arithmetic. Like you cannot do it directly with integers. you will have some seal down, or you cannot print double as well. Like it should be print mod 1 in 9 plus 7. And for that, I was directly using Edcoder library for doing values mod the given value. Any questions on problem F before we move on to the next problem? Like I have a video on how to install Edcoder library, so you can probably just take a look at it. Any question on problem F before we move on to problem G? Do we need to fix every character as the character which we want to delete one by one? Yeah, like that would be an easier way, like to solve this problem. Like you may, if you try to do some greedy or something, then you will find some corner cases there. Any question on problem F before I move on to problem G? Okay, let's move to problem G. Sakurako's task. Sakurako has prepared a task for you. She gives you an array of n integers and allows you to choose an index I and j such that I is not equal to j, ai is greater than equal to aj, and assign either ai equal to ai minus aj or ai equal to ai plus aj. You can perform this task. You can perform this operation any number of times for any I and j as long as they satisfy the conditions. Sakurako asks you what is the maximum possible max k of an array after any number of operations. Max k is defined as kth non-negative integer that is absent in the array. For example, max 1 would be the smallest missing number over here, which is 0. Or max 2 of this would be 3, since 1 and 3 are the two missing numbers here. Yeah, like sum divided by n into n plus 1. Like if you do just with integers, you will definitely get a WA. Like you need something known as modular arithmetic here. Just read out this blog and I think you should be good to start with. Like it says, like you can probably notice that in this test case, if you multiply this number by 5 into 4 by 2, you will get the required sum. But that is not the case if you multiply 8 by whatever value you have. So here, like number of pairs with 5 values 10 into 4 by 2. This gives you the required 85 sum, but that is not the case if you do it with 8. And that's why the answer 8 is wrong, but this giant number is right here. And your answer, I believe, is 85 by 10, something like that. So like this is what it says, like expected value is p by q, this print value of b qing or something like that. That is what it means. Like whatever value you print, if I multiply it with by NC2, I should get a sum here. That is not the case with 8 here. So probably let like n equal to 1 is the trivial case. You can probably have 2 if else and solve it. Let's solve this problem for n equal to 2. And like let's forget about k now. Let's try to get those two numbers as small as possible. Like probably let's start with 17 and 13. This as an array. Not 17. Let's take 43 and 13 as the two numbers. So what I will do is I will subtract 13 first. I will get 30 and 13. I will subtract one more. I will get 17 and 13. Let's subtract it one more. I will get 4 and 13. Now subtract 4 from here. I will get 4 and 9. Then I subtract 4 once more. I will get 4 and 5. If I subtract 4 once more, I will get 4 and 1. Now if I subtract 4 one times, I will get 3 and 1. And now you cannot do any more operation by subtracting here. And in fact, you see what is happening here. When I was subtracting by 13 here, I stopped only when I got 43 modulo 30, which is around 4. So after first set of operation, I ended up with 43 mod 13, which was 4 here. Now when I am subtracting again, the only time I stopped was when I got 13 mod 4. And now when I was subtracting this 4, 1, 1, the next time I stopped was 4 mod 4. So you see essentially if I just keep subtracting it, the array changes like this. We have u comma v. One of the value becomes u mod v comma v. And then this updated mod again. And probably by now a lot of people would have figured out. Like if I have two numbers, the final, 4 mod 1, right, which is 0. The final two number I will get would be 0 and g, where g is GCD of two numbers. And can you see why like this algorithm is same as Euclidean algorithm for finding GCD? Like probably you can look out for like GCD, this A mod B, keep doing it. So can I say like if I have only two numbers, I want them to be the smallest number, then the value I would get would be 0 and g. Okay, now let's generalize it to for all the larger numbers. Let's say I have A1, A2, A3, A4, A5. I start with these two numbers first. I keep doing subtraction operations here. One of the number would be 0. Let's say this, and another number would be GCD of A1 comma A2. Looks fine, right? This is still A3, this is still A4, this is still A5. Now let's say I keep doing this operation between these two numbers. One of the number will turn out to be 0 and another number will become GCD of A1, A2 and A3. This is still A4, this is still A5. And if I do operation here, I will get 0, 0, 0, GCD A1, A2, A3, A4, and the last number is still A5. Now if I do operations between here, I will get 0, 0, 0, 0 and GCD of all the numbers in here. So like if I keep doing subtraction operation, you see after some finite number of operations, I will get n minus 1 zeros. And one element would be GCD of all the numbers in the array. Any questions so far here? And once I have this, let's say 0, 0, 0, G, what I can do is like add this G here 2 times to get 2G, G, 0, 0, 0. Add this 3 times here to get 3G. Add this G 4 times here to get 4G. So basically all the multiples of I into G I would get where I is from 0 to n minus 1. Now if I do addition operations here, and my claim is like this is the smallest set of distinct numbers you would be able to get. Now just find kth missing number in this array. This ends up being the solution for this problem. Like n equal to 1 is a separate test case where you won't be able to do any operation. So treat it separately. After that, for any n greater than 1, just find GCD. You will get all the multiples of GCD including 0. And then find kth missing number in this array and you would be done with it. Like k can be up to 1 in 9. So you will have to be slightly bit more careful here. But this is essentially the solution here. Any questions on this problem? Like I can probably show you the implementation as well. First n equal to 1 separately. If a0 is like kth smallest element is k minus 1. So if a0 is less than k, you print k, otherwise you print k minus 1. This is done separately. Now find GCD of all the numbers. And all the remaining numbers would be all the multiples of GCD where j equal to 0 to n. Now like I start with answer equal to k. I count all the numbers less than my current potential maximum. Let's keep it just so. I have sorted as well, like this array sorted. Total j from 0 to j, you will have j plus 1 elements minus this is the missing count. And if missing count is equal to k, like this is the smallest number we have. So I can directly print j and add a break here. And this ends up being the solution for problem G. Looks like I'm missing something somewhere. If let's say number 5 is missing, one and 10. So from 1 to 10, 10 numbers would be missing. Second test case. Okay, 11 is the expected value. One second, like from 1 to 3. If A0 is less than K minus 1, like 0 to K minus 1, we will have K numbers. So K is the default answer. Yeah, like probably like Neil, you were right. Don't want to make n minus 1 zeros, but like the contest ended up changing the problem statement to make all AI greater than 0. And no, wait, I think I see why you got WA. Because here we are assigning AI instead of AJ, so probably going to 0 might not be the solution here. I see where the problem is. I agree. So probably at least that was the reasoning I had. 1 second, let me see what I can do. If I can't make numbers 0 here. If AI equal to, if assigning to J was fine, then we would have been good. But 1 second. From 0 you can't backtrack. That's correct. No, because AI is greater than, like, this condition is a problem here, I see. Okay, like for example, if we have this 0, 0, 0 and 4 here, now like let's say if I choose I cannot choose any of these as I, because I want AI greater than equal to AB. So like only addition I can do here would be 4 plus 0 only, and that does not changes the arrays here. Looks fine. 1 second. Like let me see like what we can do here then. Like at least that was it. Yeah, like probably the another thing I can do is like here, if I am here, I can just keep this as the last operation here. So both the numbers are 1. Like let's keep it like this here. So that these two numbers instead of 0 are GCD here. A1 comma A2. So instead of zeros, what we can end up with is just all the numbers as GGG. Let's say this is where we are. Yeah, like I now understand what the problem was. I was assuming probably GCD 0 comma 0 is a problem. Now I can add this G to all the numbers here to make them 2G. Or probably I can subtract 1 to make one of them 0, because that's what I want. And add everything else for 0. And now I can add on the larger number, right? So I can add this G here 3 times to make this 3G. And I can also add G this 4 times to make it 4G. And I can keep going. Because I always add on the larger number. What I can do is I do not make any zeros first. I make all the numbers equal to G first, which is GCD of all the numbers. And then I change one of the G's to 0. And for all the others, I can keep adding to get 2G, 3G, 4G, and so on. And like probably like the end solution is same, but the reasoning we had was correct. And this explains why we had a rejudging here. And why all AI greater than equal to 1 was made. Yeah, like I definitely did the problem wrong, and probably let me see what condition I had for n equal to 1. Mm-hmm. So let's just keep it like this. Yes, like most of the solutions would be wrong, I think. Because you cannot change 0 to the larger number, so your answer will end 1 second. Oh, I understand what the problem is. Like the sample cases I have is wrong. I have older sample where the numbers were 0 and 0. One second. N equal to 1. Looks like I'm missing some edge cases here. Let me see. Count of all the numbers. Let's start with k minus 1. 1 second. Okay, I will have to probably change out expected output as well. Yeah, looks fine. So yeah, sample was also changed for this problem, and my problem statement had older samples. Yeah, like I definitely directly got an AC, not a WA on test 3 when I started. Yeah, so like probably like two people in my friend list had a lot of WAs. One Neil, you were there, and another Dominator was there. Like Dominator also had a lot of WAs here before it was marked as accepted here. So like this was problem G. Any questions on problem G before we move to problem H? So problem H says Sakurako will soon take a test. The test can be described as an array of n integers and a task on it. Given an integer x, Sakurako can perform following operation any number of times. Like x is fixed, you can choose any integer I which is greater than equal to x and then change its value to ai minus x. Using this operation any number of times, C must find minimum possible median of the array. Median of an array of length n is defined as middle element in the sorted array. That is this position when n is even and this position when n is odd. Sakurako knows that the array but does not know value x. So sometimes she let it slip that one of the q values of x will be in the test. So Sakurako asks you what is the answer for each k, and like in input there are many different k's given to you. Many different x given to you. So probably let's first try to solve it for a fixed x and then let's see how to solve it for different queries here. So for example, let's pick one of the samples here. Let's pick this one. This one looks nice. One, 2, 6, 4, 1, 3, and let's say our x is equal to 3. First thing, let's try to reduce each element to minimum possible by doing the operations here because we want minimum median at the end of the day. So like if you try to reduce each element minimum possible, you can probably reduce the median there. Like median is the sorted array. And if you are looking for this minimum value, all of these should be as small as possible if you look at intuitively. Reducing whatever values remain here might not be necessary, but let's just probably do it once. So our first task reduces to subtract 3 from all the numbers as long as you can. So subtracting 6 minus 3 becomes 3, and then subtracting 3 again, this ends up being 0. Yeah, like we can first take mod x, but that is where we will end up. Subtract 4 from 3, subtract 3 from 4, you will get 1 here. Subtract 3 from 3, you will get 0 here. Or you can essentially say like this is also equal to, like when you keep subtracting x, as we have seen in the GCD problem, each I changes to ai mod x here. So this would be our array if we try to reduce each element to minimum possible value we have. Like let's sort it. There are 2 zeros, there are 3 ones, and then there is a 2. There are 6 numbers here, and it says in case of even number you should choose the 4th element. So for this array, the answer for x equal to 3 would be 1. Let's probably see, like sample does not have a 3, that's fine. So like any questions, like if there were no queries, just one value of x, how you would do before you proceed on for queries? Okay, let's probably do it slightly in a different way. Like let's, like as we have done some more problems recently, let's try to binary search for the median. Like for n equal to, if we had just one value, the answer is simple. For each value, take mod with x and then sort it and find the required value. But let's do it in binary search way. Like we will binary search like for the median from 0 between x, where we will say like our required median is greater than equal to 0 but less than x. Those are left and right boundaries. Then we will have some mid there. I would have some mid. Let's try to count how many values I can get less than equal to. That can become less than equal to mid. Like for example, we know in array with 6 element, we want 4th smallest value. Like let's just count how many values can be less than mid here. If this count is let's say 2, then we assign our left boundary to mid. And let's say if this count is 5, then we can assign our mid boundary to mid. And we can keep going, and at last we can print mid whatever here. Probably I have read a bit faster here, but if anyone does not get the idea how we are doing binary search, I can try to explain it in a bit more detail. But I think it had came frequently 2-3 times in the recent streams I have done. So I might skip the idea for like how can we use binary search to find a median, and by counting how many elements less than mid are there, if people in the chat have got it. Okay, I think I will probably skip. And now our problem reduces to like count how many values can become less than mid for a fixed x given all the values of j. And you can see like we are taking each value as mod, right? Mod x. So what we need is for all j into x, comma j into x plus mid minus 1. We need how many values are there in this for all j equal to greater than equal to 0 and less than equal to n by x. Like we essentially need this for all the values. Like any value which is between j multiplied by x and j multiplied by x plus mid minus 1 can be the value. If you take it mod x, you will get value between 0 to mid minus 1. And now because all the values in the array are from 1 to n, you can iterate this j from j equal to 0 to n by x. And like this count you can obtain in order 1 by probably maintaining like for each k how many values are there less than equal to k. Like probably you can have first a frequency array and then like prefix sum of that frequency array. Like you can pre-compute it earlier faster. So overall like binary search will take around log x time, and for checking each for loop will take around n by x time. So this is slightly worse than the original problem we had, where we are doing a few more things. But within this time complexity, we will get the max here over. And the last idea I had was like queries can contain each x multiple time. It does not say all the x are distinct here. But whenever you compute value, answer for some x, save it somewhere. So that next time if the problem says like give me the answer for x equal to 3 5 times, you run this algorithm only once, and for 4 times you just use this pre-computed value. So overall like if all the x are distinct, overall time taken would be n by 1 log 1 plus n by 2 log 2 plus n by n log n. If all the values are different, then this would be your total time, because you are not running the same algorithm more than once. So for any x, if you ask it for duplicate the time, you won't be doing the iteration faster. Probably these all logs x are less than log n. So our solution turns out to be 1 by n by 1 plus n by 2 n by n log n. And like yeah, like printing values for all 1 to n would have been really better, I agree. And like this is the harmonic sum, or probably let's say harmonic series, and this has appeared quite frequently, and we know that this value is approximately equal to n log n. And you have this log n for binary search as well. So overall this would be our time complexity, and this is pretty fast for whatever the constraint we have, and we're up to 1e5. So this ends up being my solution here, and probably I will show the code as well. Like first thing I did was take array as input, and then for each array count how many values, like frequency array, whatever I call. Like all the values which I have less than equal to that value. Like there are no zeros, so we don't really need it for zero. Now this is my solve function which keeps for calculate for some mod value. Calculated, like let's just fill it with -1 before. So whenever I want sum for calculated, if value is not equal to -1, this means I have already calculated it. Just return it. Otherwise, I will use binary search to calculate it. I will also assign that value and return that value. So my solve function reads input outputs for it. Now a binary search here. My range are like the answer from -1 to mod. I have a mid. And now like this checks like is my median greater than is less than equal to mid I have. If the answer is true, I am moving my right boundary. If the answer is false, I am moving my left boundary. Mid IDX, like this is my mid index. You can probably have to if and else based on the value of n, but that was fine. Like first I count how many values would be there in each range. So I start from all j equal to 1 to j by mod. My left boundary is j into mod which I want, and right boundary is L plus mid. Count of elements I have is like let's first, if n is positive, then the number of values I have between L to R is less than equal to R. Count of values which are less than equal to R minus L minus 1. This is the count of values which are between L to R. And if L is 0, like last occurrence, like, and if this value is greater than my mid index, then I shift my right boundary, and otherwise I shift my left boundary, and we are done with it. I think probably there can be some off by one issues here, like because I am calculating all the values up to mid here and then doing some left out, but you can probably figure it out. Like the implementation might not be exactly what I have explained, but some off by one can be there. And this ends up being the solution for H. So any questions or any problem or any other questions we have? If not, then I will probably, I'm mostly done with this stream. Sure, Neil, you can be a mod. Probably, I don't know the difference between managing and standard mode. I will probably take a look at it and probably switch it there. But at least you are mod right now. I can explain like the brief ideas for H again. And I will probably so like my main idea was first let's try to solve it for some fixed value of X. And the main intuition I had was because we want minimum possible value of median, let's try to reduce each value to as small as we can to begin with. So I took some array from input. Like for example, this when I was solving for k equal to 3, I subtracted 3 2 times here. I subtracted 3 one time here, I subtracted 3 one time here. So I ended up in 1, 2, 0, 1, 1, 0, and now all the values are less than 3, so you cannot subtract anything here. And what you can probably notice is like this value is essentially assigning equal to each AI equal to AI mod x. So like if I have to solve only for one value of x, this is what I will do. I will first change each AI to AI mod x. Then I will sort this array and look at which value is in the middlemost position, and I will directly print it. But the problem here is like the problem statement asks us to find for many different values of x, and those count can be up to 105. So the next idea was I can probably do a binary search on this median. I will have some boundary from L to R. I will find some mid, and I will see like what is the last place where this mid can appear in my sorted array. Like if you look at, for example, here, the example I had, the last index up to where 0 can appear would be this. Last index where 0 can appear, 1 can appear would be this, and last index where 2 can appear would be this. And my median is the smallest value which comes after my median index the first time. So if I look at count of values less than 0, less than equal to 0, that count is 2. Number of values less than equal to 1 is 5. Number of values less than equal to 2 is 6. And because median is the fourth index here, there are 6 values, 6 plus 2 by 2 we had here. So there are 2 values greater than equal to 4, but this is the smallest one, and our median is this. Following up with this idea, like once I have some fixed some mid, I have also fixed some mod, and I want to count how many values, like what is the last index, like where the mid can appear, or like how many values can be less than equal to mid I have. There the idea was like all the values which are between 0 to mid would be like there would be some j into x. X is the original value we had, and j into x plus mid. Like I need how many values are there between these ranges, and where j is between 0 to n by x. This I can probably maintain a prefix sum of frequency arrays to directly get for a particular range how many values are there in some order 1 there. And overall my time complexity to find for some fixed x would be log x for the binary search, and n by x for this for loop to count how many values are there in mid. So this is some another way to find what would be the max I have in some worse time complexity, where this is my time complexity. The next idea I had was like if we keep doing it for each value of x, then you see problem statement asks for x equal to 1, we will always do n log n, and q queries would be there. So the next idea was like whenever you calculate value for some x, save it somewhere and don't run this long algorithm again. Just directly look at this array and print it. And the idea was like if you start doing that, then only different values of x will matter over here. And in the worst case, one problem can ask you for x equal to 1, some x equal to 2, x equal to 3, up to x equal to 1. And in that case, like the total time taken would be sum of these n by 1, log 1, n by 2, log 2, and so on. And all these log 1, log 2, log 3, etc. are less than log n. And what we essentially need is like the time taken would be n by 1 plus n by 2 up to n by n. This sum multiplied by log n. And what we know is like this sum is harmonic series, and it's quite well known like this sum is approximately equal to n log n. And this log n factor here, total time taken being like n log square n would be our time complexity. And like this would be the idea I had. So like this was the main idea I had, and then probably I had a code as well which was doing the same thing. First I calculated frequency of each number. Then for each number I calculated how many values are there which are less than equal to that number. Then I have vector which says if I have calculated, if it's calculated then this value is not equal to -1, do some positive. I have a solve function which takes x and says give me the answer for this as a mod. I look whether I have already calculated it. If I have already calculated it, I directly return it. Otherwise, I am doing a binary search here to find the value. I assign that value to this calc mode and return that value out. In the binary search, like I have some mid, I see like what can be the last place where mid can be or how many values are less than equal to mid. For that count, I have this variable count. I run a for loop from j equal to 0 to n by mod. This would be the range which I previously showed you. I see how many values are there in this range. If value is positive, you can directly take this or otherwise this and see if this value is greater than equal to what is the median count we have. Return a true here and that ends up. So if this check function returns true, you change the right boundary. If check is false, you reassign your left boundary. And this ends up being the solution for problem. So yeah, this were the 8 problems we had today. Can you tell us about practicing pattern and way of selecting problem to practice efficiently? Is this just random solving enough or do we have some different strategy to go past expert? Like the first strategy I have is to participate in contests and try to solve the problems that you could not solve. And if these contests are not enough, then you can probably also try to do some virtual contests. Or if you are looking something out for practice, then there is a CSES problem set, which contains quite a lot of standard problem. You can try solving these as well. And then there are some topics on USAO guide as well, USACO guide, Computing Olympiad guide. Here there are 4 sections: bronze, silver, gold, platinum. Bronze is around due 3, platinum is around due 1, 0.5 something like that. So probably if you are expert, you can probably start by gold here. There are many problems here. Looks like around 357 problem in this problem set and 25 different models. You can probably read stuff here, try to solve problems here, and probably that would be my way. And another way can be try to do virtual contests, assuming it's the right contest, and you can keep going. This would be my generic advices, and this is pretty much I also shared on my Discord server. So you can probably take a look at it again. And this is what I have been doing. Some people may have some different ideas, but that's what I essentially did over here. Like on the Discord server, I have this channel where like these are the exactly same advices which I just told I have ended up writing here. So you can probably refer it here as well. So any more questions before we call it a day today? Like math and number theory, it depends how do you define. Like you don't really need a lot of hard math, but you will definitely need some ideas which appear too frequently. Like for example, the GCD one here, the way to recognize what is going on here can be another way. In problem B, I into C plus A, like I'm not sure, but I can probably take a look at it based on my brain. Like, is there a way to practice proof? Like, probably like you can try writing it rigorously, but generally that's what not people do. But you can probably try to make some planes and convince yourself, I think would be the way. Like motivation to continue should be like, I will say it's a sport at the end of the day. You don't look out for motivation to play badminton. Do it if you enjoy it. If you don't enjoy it, just leave it and go play badminton or something else. Like CP is not the end of the world. So probably best way to crack DSA question for interview, like I think if your target is interview, like you can probably like a lot of different seats are there. You can probably try out them. Like you can probably search for top 100 interview problems on lead code, top 100 easy problem, top 100 medium problem. You can try to solve them. And I think lead code has one problem of the day every day. You can probably try solve them. And like my recommendation is like most of the time, if you are immediately looking for a job, lead code is probably the better way to spend time at rather than code forces. The way I say it is like ROI you will get for let's say spending some X amount of time on code forces and lead code. Like lead code will give you better result if the target is only interviews and the X is very small. Like there is a good chance like probably the problem you see on lead code today might be asked in the interview tomorrow, but that might not be the case for code forces. But if it's probably long run, then you can probably read. Should one read about like you should probably read about expected value and like there is a two lecture on expected value by Ricto as well. Some and expected value. You can probably refer these two blogs by Ricto and there are lectures as well. Part one, part two. Try to learn about it and understand it more. Like I don't think expected value is rare. Like it comes too frequently. Just that in current context it was slightly similar. No, I think like I have mentioned before, like if you are probably looking for a job, like lead code might be a better way to start right now. Like you can probably start solving some modules from here. Like there are interview top, interview problem, etc. And I would say like this would be and I think like this is mostly done for the stream today. And I think I will probably end the stream now. Thanks everyone for joining today. Mhm.